Hello and welcome back to the Deep Dive. We have a really interesting stack of documents today.
We do.
On the surface, if you just glance at the title, it looks like we're just prepping for a certification exam, specifically the VMware 3V0-23.25.
Yeah.
But as I was reading through the material, I realized we're actually looking at something much bigger.
Yeah.
We're looking at the blueprint for the modern software-defined data center.
That's exactly right. I mean, it's so easy to get bogged down in the acronyms vSAN, VCF, OSA, ESA. But what this exam is really testing is your ability to architect a cloud that, doesn't fall over when you pull a cable.
Right.
It's about understanding the logic that keeps the lights on in enterprise infrastructure.
Which is a skill we all need, whether you're sitting for an exam or just trying to survive a Monday morning meeting. But before we get into the architecture wars and the logic puzzles, Let's set the stage. If I'm walking into the testing center to take this thing, what am I signing up for?
Yeah.
Because the logistics alone look like a bit of an endurance test.
It is definitely a marathon, not a sprint. The exam guide specifies a duration of 145 minutes.
Wow.
That's nearly 2.5 hours of intense focus. It's longer than most feature films.
That is a long time to be staring at diagrams without a popcorn break.
It is. And in that time, you're not just answering simple trivia. You're tackling between 60 and 70 questions, and the format varies.
Wildly, from what I saw. It's not just single choice.
Not at all, and that's where a lot of people trip up. You have your standard multiple choice, sure, but then you also have multiple selection, where you have to pick, say, the 3 correct answers out of 5.
And if you miss one, you don't get any points for that question.
Usually no. Then there are the drag and drop questions, which are really testing your understanding of workflows and processes. And finally, matching questions.
The drag and drop ones always stress me out. It feels like the stakes are higher. It feels like you have to know the order of operations, not just...
That's a great point because that's exactly what they're testing.
Not just the isolated facts.
Right. It tests logic, not just memory. Can you actually build the thing in the right order? And with a passing score of 300 on a scale of 100 to 500, there isn't a huge margin for error.
Okay.
So our mission today should be to move past just rote memorization. We're going to look at the key concepts vSAN 8 and VMware Cloud Foundation and really unpack the why behind the answers.
I like that plan. Let's start with what I'm calling the tale of two architectures. The study materials make a huge distinction between two ways of building storage in vSAN, the original, or OSA, and the new express storage architecture, ESA. It feels like a generational divide.
It really is. I mean, this is arguably the biggest shift in vSAN history. You have the legacy way, which served us well for a decade, and the new way, which is built for the future.
So let's start with the classic, with OSA. We have a practice question here that asks about the function of a cache-tier device. And the answer is that it's for temporary storage, for write and read operations. But let's unpack that. Why temporary storage? Why not just write the data where it lives permanently?
To understand that, you have to think about the era when OSA was designed. We were dealing with, spinning magnetic disks or maybe early slower SSDs.
Right.
If you tried to write data directly to a spinning disk every time a VM needed to save something, the performance would just be terrible. It's physically too slow. The read-write head has to physically move.
So OSA uses a two-tier system to solve that physics problem.
Exactly. The cache and the capacity. The cache tier is your sprinter. It's a high-speed SSD that catches the data as soon as it hits the host. It sends an acknowledgement back to the VM almost instantly. Yep, got it. You can keep working.
So the VM is happy?
The VM is happy because the write felt instant. Then in the background, the system destages or moves that data from the fast cache tier down to the slower capacity tier.
So it's a buffer.
Yeah.
Like a waiting room for data where the service is really fast before it gets sent to the archives.
That's a perfect analogy. It buffers writes to hide the slowness of the back-end drives. And for reads, it keeps hot data stuff you access all the time close by. It was a brilliant architecture for the hardware of 2014.
But now we're in the new world. We have ESA, the Express Storage Architecture. The question here asks about the primary hardware requirement for it. And the answer isn't just any disk. It is very specific. High-performance NVMe flash devices.
And this is where the game changes completely.
But why is it a requirement? Why can't I run this fancy new software on my old SSDs?
Because ESA isn't just an upgrade, it's a total rewrite. The engineers looked at modern hardware, specifically NVMe drives, and they realized that the old software stack, the one with the cache and capacity tiers, it was actually becoming the bottleneck.
The software was the slow part.
Yes, NVMe is so fast that it doesn't need a cache tier in the traditional sense. It doesn't need a buffer because the capacity drive is already faster than the old cache drives ever were.
So ESA is a single-tier architecture.
Effectively, yes. But to make that work, the software assumes it has massive parallelism and incredibly low latency. If you tried to run ESA on an old SATA SSD, the software would just be waiting around for the hardware constantly. It's like trying to put jet fuel on a lawnmower. The engine just isn't built for that kind of throughput.
That's a great way to put it. So OSA needs the cache to hide slow hardware.
Yeah.
ESA demands NVMe because the software refuses to be slowed down.
Precisely. And for the exam, that distinction is critical. If you see ESA, you must think NVMe and a simplified single-tier structure. They're totally linked.
All right, let's zoom out from the drives and look at the bigger picture. The exam heavily features VMware Cloud Foundation, or VCF. This seems to be where all the complex logic lives.
Think of VCF as the factory that builds and manages the clouds. It takes vSphere, vSAN, and NSX and wraps them all into a unified platform.
There's a really tricky question here regarding the management domain. The scenario is you're doing an initial deployment day 0, you're plugging things in. It asks, which storage type is required?
This one catches a lot of people off guard.
Right, because usually VMware is storage agnostic. You can use Fibre Channel, ISCSI, NFS, whatever you have. But here, the answer is explicitly vSAN. Why? Why is it mandatory for the management piece?
It comes down to automation and what we call the chicken and egg problem. When you're first powering on this entire cloud, you need a place to install the brains of the operation, the SDDC manager, the vCenters, the NSX managers.
Okay.
If you rely on external storage, you first have to configure zoning, LN masking, all these specialized drivers before you can even get started.
And that requires a human.
Exactly, or a very complex script. But VCF is supposed to be automated out of the box. By mandating vSAN, the installation routine knows exactly what hardware it's dealing with. It can claim the local disks, build a vSAN data store automatically, and deploy the management appliances without any human intervention.
So it's about control. It ensures the foundation is self-contained and predictable.
100%. The management domain is the control plane. You don't want your control plane dependent on some third-party storage array that might be misconfigured. They keep it close to the vest with vSAN.
Okay, that makes sense. Now, once you have that management domain, you need a place to run your actual apps. The material calls these workload domains. The question asks, what defines the logical boundaries for compute, storage, and networking? And the answer is the workload domain. But I want to dig into that logical boundary part. Why do we need boundaries? Why not just one giant cluster?
Imagine a massive apartment complex where everyone shares the same thermostat and the same fuse box.
Oh, no.
If you need to shut down the power to fix the wiring in one apartment, everyone loses power. That's a monolithic cluster.
That sounds like a nightmare.
It is. Workload domains let you carve up your infrastructure into separate containers or sandboxes. You might have a VDI workload domain for virtual desktops and a database workload domain for high-performance SQL.
And they're isolated from each other.
They're managed by the same brain, the SDDC manager, but they can have different personalities. The VDI domain might run on older hardware. The database domain might use that fancy NVMe ESA storage we just talked about.
And crucially, they have different life cycles.
Exactly. You can patch the VDI domain on Tuesday and leave the database domain alone until next month. It limits the blast radius. If an upgrade goes wrong, it doesn't take down your critical databases.
Speaking of upgrades, let's talk about the conductor of this whole orchestra. We've mentioned vCenter and we've mentioned SDDC Manager. The exam asks, who orchestrates lifecycle management? The firmware, drivers, all that.
This is a classic point of confusion. We're all used to vCenter being the king of the hill.
But the answer here isn't vCenter, it's SDDC Manager.
Right. And here's the distinction. vCenter is fantastic at managing virtual machines. It makes sure your servers are running. It handles HA if a VM crashes. But SDDC Manager manages the platform. It looks deeper.
At the physical servers.
Yes. It checks if the firmware on your network card is compatible with the driver in ESXi 8.0.
That compatibility matrix is famously difficult to manage by hand. I've seen spreadsheets that look like conspiracy theories trying to track all that.
It's impossible at scale. SDDC Manager automates that. It acts as the guardrails. It won't let you apply a patch if it knows it's going to break compatibility. So, for the exam, you have to remember, vCenter is for the passengers, the VMs, while SDDC Manager is for the airplane itself.
I love that distinction. Let's move into what I call the gotcha numbers. Every exam has them. The specific constraints you just have to know.
Engineers live and die by constraints. You have to know where the edge of the cliff is.
The first one is about stretched clusters. This is where you have one cluster spanning two different physical sites. The question asks, what is the maximum round-trip time, or RTT latency, allowed between the sites?
And the answer is 5 milliseconds.
5 milliseconds. That is incredibly fast. Just for context, a blink of an eye is what, 100 to 400 milliseconds? Why is 5 milliseconds the hard limit?
It comes down to the physics of synchronous writing. In a stretched cluster, when a VM writes a piece of data, vSAN has to write it to site A and site B.
At the same time.
Right. And it waits for site B to say, I got it, before it tells the VM, save complete.
So the VM is technically frozen while the data travels across the city.
Briefly, yes. That travel time is the latency. If you have 5 milliseconds of latency, every single write operation is delayed by at least 5 milliseconds. If you push that to 10 or 20, your application performance just falls off a cliff.
Users start seeing the spinning wheel of death.
Exactly. So 5 milliseconds isn't just a random rule, it's the threshold of usability. It effectively limits the physical distance between your data centers.
You're looking at metro distances, really.
Maybe 100 kilometers max, depending on your fiber.
Okay, next number, RAID 5. Everyone loves it because it saves space compared to mirroring. But there's a catch in vSAN. The question asks, what is the minimum number of hosts required in a standard vSAN cluster to run RAID 5?
The answer is 4 hosts.
I feel like a lot of people would guess 3. 3 feels like a magic number in clustering. You always buy 3 servers.
It is, usually. But for RAID 5 and vSAN, you have to look at the math of erasure coding. The data is split into components. 3 data components and 1 parity component. 3 plus 1 equals
4. Simple math. You need 4 separate physical locations to store those 4 pieces.
Exactly. If you only have 3 hosts, you physically cannot place the components in a way that survives a host failure. If you lose a host, you'd lose 2 pieces of the puzzle and the data would be gone.
So if you're a small shop with a 3-node cluster, you're stuck with RAID 1 mirroring.
Generally, yes. If you want the space savings of RAID 5, you have to pay the entry fee of buying a 4th server. It's a trade-off.
That's a crucial trade-off. All right, let's head into our final section, keeping it safe and healthy, security and ops.
Always the most important part. If it's not secure, it doesn't matter how fast it is.
Let's talk encryption. Data at rest encryption is pretty standard these days. The question asks, when you enable vSAN encryption, where are the keys managed?
The answer is in an external key management server, or KMS.
Why external? Why can't vCenter just hold the keys? That seems easier.
Think about a physical security breach. Imagine someone breaks into your data center and literally steals a server rack.
Okay.
If the encryption key is stored on that server's local disk, they have the lock and the key.
They can just boot it up and read all your data.
Right. By requiring an external KMS, we separate those duties. The server has the encrypted data, the lock, but it has to reach out over the network to the KMS to get the key. If the server is stolen and disconnected, it can't get the key. The data is just garbled.
It's the safety deposit box model. You have one key, the bank has the other. You need both.
Precisely. It's a fundamental security principle.
Okay, now maintenance. Things break. You need to put a host into maintenance mode. The question asks, which option ensures all data is moved off that host before it shuts down?
The answer is full data migration.
That sounds intense.
Yeah.
That sounds like the nuclear option.
It is the heavy lift, for sure. When you select that, vSAN evacuates every single bit of data from that host to the other hosts in the cluster. It completely empties the server.
That must take a long time.
It can take hours depending on how much data you have. But it guarantees that while that host is offline, you still have full redundancy for all your data. No risk.
So you pay with time to buy safety.
Correct. The other main option, ensure accessibility, is much faster, but you might be running with reduced redundancy if another drive fails while you're doing maintenance.
You could lose data.
You could. Full data migration eliminates that risk.
So if you're a paranoid admin, which is the best kind of admin, you choose that one. Finally, let's talk about checking the pulse of the system. The question asks about a tool in vSphere used to proactively check vSAN health.
And this is Skyline Health.
I really like the word proactive there. Most IT tools feel reactive. They scream at you only after the server is already on fire.
That's the legacy way, right? Waiting for the phone to ring. Skyline Health is different. It's constantly running checks in the background against a database of known issues and best practices. It might tell you, hey, your driver controller firmware is slightly out of date, and that specific version is known to cause problems.
So it fixes the problem before it even becomes an outage.
Or at least it warns you very clearly. It links you right to the knowledge base article with the fix. It's like having a VMware engineer constantly auditing your setup 24/7.
That's invaluable. It shifts the mindset from break-fix to wellness.
Exactly.
Well, on that note, we are going to wrap up this deep dive. For everyone facing the 3V0-23.25 exam, good luck. Read the questions carefully, watch out for those select 3 options, and remember the logic. Thanks for listening, and we'll see you on the next deep dive.
Goodbye, everyone. Stay curious.